Hello, welcome back everyone. My name is Inu Sarabi Isa Bodmas. Welcome to Electronics tutorial. Today we are going to solve problem from stress strain diagram. From the screen, here is a problem we are going to solve. A galvanized pipe has a constant diameter of 40 mm and a thickness of 10 mm subjected to a compression force of 60 kN as shown in the figure. Determine the normal stress in the pipe. That is the question. So this is very straightforward question, but the only issue is about the thickness. Most of the people get confused when they show thickness or internal diameter in certain problems. So what we mean by thickness or internal diameter of a given problem is that the structure is a hollow one, because there is a big dichotomy between the hollow structure and the normal structure. So whenever you saw thicknesses or internal diameter, that means there is a hollow. It is hollow. So in this case, when you have a thickness or internal diameter, for you to get the area, you need to subtract the area covered by the internal diameter or covered by the thickness for you to get the area of the hollow shaft. So in this case we have a thickness, so we're going to subtract the area of the thickness to get the normal cross-sectional area of the figure. So let's go straight forward to solve the question and see. So now in these problems we have a force apply which is 60 kilonewton compression, and we have the diameter, the outer diameter of 40 millimeter, and the thickness is 20 millimeter. So now in this case, as we said, the area should be equal to phi. If there is no thickness, we go and say phi d square over 4, phi over 4 d square. That's normal. But since there is a thickness, we need to subtract the area of the thickness, which is t square. It's like we are factoring pi over 4 out. Therefore, we substitute to get the value. So this is equal to phi over 4 into 40 square minus 20 square. So phi is 3.142 per calculator, or 22 over 7. So just spread the value and get the value of the area, which is 942.5 millimeter square. So now we have the area and we have the force. So for us to get the normal stress is always equal to the normal force all over the cross-sectional area. So the normal force is 60 kilonewton all over the area, which is 942.5, which is equal to 0.064 kilonewton per millimeter square. So this is the stress, and that is structure. Thank you very much for bearing us. We look forward to seeing your question whenever you have issue with this tutorial. Thank you very much for bearing us.